Good morning, my YouTube viewers. It is Crystal here. I'm just here because I wanted to do a code review. And basically what I wanted to do was I've been studying some algebra and it's a 15-hour video. So I wanted to take a break from that 15-hour video and do a community competition on Kaggle. So I entered this community competition on Kaggle, and the title of it was Show Me the Money. And what it's about people who are likely to default on loans. And then you're supposed to predict whether or not they're likely to default on loans. But the competition itself was written in Spanish, I believe. And because it was written in Spanish, I can't really tell you the problem statement because it was all in Spanish. But whenever I looked at the data set, I assumed that it was whether a person was likely to default on a loan. So that's my assumption. So we're going to go ahead and do the code review on this that I did for a little bit of, well, I did it for a bit of relaxation, really, if you want to call it relaxation, because I was studying and I wanted to take a break from studying, so I did it as a break. So you can see here that I did 68%, 68.7% on the model that I used, and I was number 3 on the leaderboard. So I can't give you a problem statement because the problem statement is written in Spanish, and if you're watching my video, then at the very least you're going to understand English. So there's no problem statement here, but I'm assuming it's whether people are going to default on a loan. They're likely to default on a loan. So the first thing we want to do is we want to create a Jupyter notebook, which I created in Kaggle's free online Jupyter notebook, and it's stored in the directory for the competition question called Show Me the Money. And so after we've created our notebook, we want to import the libraries. So we're going to import NumPy as NP. That's your numerical computational library and also it creates NumPy arrays. We're going to import pandas as PD, which is for your data processing, and it creates data frames and series. We're going to import OS, which goes into the operating system, and we're going to import matplotlib.pyplot as PLT, which is a graphics library, and we're going to import Seaborn, which is also a graphics library with statistical elements to it. Then we're going to load the files. We're going to use OS to load the files, and what that does is that goes through a for loop, and then whenever it goes through a for loop, it just prints out the directory name and the file name. And you can see that we have 3 files being train test and submission. Then after we've loaded the files, we're going to use pandas to read the files. So the first one is train equals pd.read.csv, and then the file name. And so the 3 files that we're going to read and convert to data frames are train test and submission. So you can see train here, which it gives you an ID, gives you serious delinquency 2 days, revolutionizing, number of times 50 days not past due, debt ratio, monthly income, number of operation credit lines and loans, number of times 90 days late, number of real estate courses, number of times 60 days late, and number of dependents. And the serious delinquency 2 years, that's your target. Then you've got your test, which is exactly the same as the train, except it doesn't have serious delinquency 2 years. You've got your submission, which is your ID, and your serious delinquency 2 days. And now we're going to analyze the train file. We're going to see what we've got in the train file. We're going to see if there's any null values. We can see if there's any null values, which there are. So we're going to drop any null values in from the train data set. We're going to check for null values in the train file again, and we've deleted all the null values, or we've dropped all the null values. We're going to do an analysis on the target, which is serious delinquent in 2 years. And as you can see, most of them are 0, but a few of them are 1, and that indicates that you have a class imbalance. I did a scatter plot on monthly income to debt ratio, so you can see really the higher their monthly income, the lower their debt ratio, and some people had a really high debt ratio. We did a scatter plot on number of dependents on debt ratio, and you can see there tells you the higher the number of dependents, the higher the debt ratio. We're going to combine our train and our test set. But the first thing that we have to do is we have to define our serious delinquent in 2 years as your target, and then we drop that, and then we append the test to give you combi. And you know what I forgot to do? I forgot to delete the ID, which I think I'm going to go back and delete the ID when I finish this code review. We're going to analyze combi. You see we've got some missing values. So what I did was I put a for loop in there, and we filled all the missing values with it. If it was an int, it was filled with median, and if it was a float, it was filled with mean, because we have to impute the missing values. We can't delete them. The reason why we can't delete them is because the test file has to be the same. It has to look like the test file on submission, otherwise Kaggle won't accept it. So we have to keep the rows in there that have null values, and the only thing that you can do about that is to actually impute them. So we're going to see if we have any more null values. We don't have any more null values. And then now what we do is on the age was a string, and you don't want the age to be a string. So what we're going to do is we're going to take the last character off the age because it was a Y, and then we're going to convert it from a string to an integer. So you can see here, let's see if we can find age. There you go. We've taken off the last character and converted it to an integer. So we're going to check info again, and you can see that age is no longer an object column. I did a scatter plot with age and debt ratio. So you can see here, you've got a few outliers over there, but you can see a scatter plot with age and the debt ratio with a few outliers. Now we're going to create a heat map, and when we created a heat map, you can see that there are 2 columns in particular that have a really high correlation. One is number of 90 days late, and the next one is number of 89 days late or 60 days late. And so those columns have a really high correlation. So what we're going to do here is we're going to insert code to remove the columns that have a high correlation. And then so now what has happened is it has removed 2 columns. But I think there are 3 columns in particular that have a high correlation. One was number of 30 to 59 days past due notice. The next one is number of 90 days past due notice. The next one is number of 89 days past due notice. So those columns have a really high correlation. So we remove those columns because they're redundant information. And what we have done is we have normalized COM-B. What we've done is we've converted all the cell values in COM-B to values between 0 and 1. And the reason for that is because it is easier for the model to train and fit the data into it if the data is closely related. We've broken up our X and Y values, so your Y value is your target, which we previously defined, and then your X is your COM-B to the length of train, and X test is the COM-B length of train to the end. And now what we did was we inserted code to split your data set into training and validating sets. And then we select the model. And in this instance, I selected logistic regression. I tried another model, and when I tried the other model, it didn't do as well. It was a neural network. It was sklearn's neural network. It was MLP classifier, and it didn't work as well. It gave you a high accuracy when you trained and fitted the model, and it gave you a high accuracy when you tested on the validation set, but when you tested on the test set, it gave you a lower accuracy. So since it gave me a lower accuracy, I wanted to stick with logistic regression. So we predicted on the validation set, and you can see that when we trained and fitted the model, we had 72% accuracy, and we predicted on the validation set, we had 73% accuracy. We had a confusion matrix, so you can see how many zeros it selected and how many ones it selected. So this actually was better than whenever I used the MLP classifier. So logistic regression does do a better job on imbalanced data sets because logistic regression has a function in the parameters. You can tune the hyperparameters to class weight equals balance, and then when you do class weight equals balance, it inversely weights the ones and the zeros. So it did actually do a better job of selecting the ones and zeros than the MLPC did. We're going to compare Y-val to Y-pred. So you can see that. So you can see that we had more predicted ones than we actually had ones. So that was one problem. We're going to predict on our test set. And then when we predicted on our test set, we're going to take the test set and we're going to put the predictions into the submission serious delinquent in 2 years column, and we're going to convert the submission to a CSV file, and then we're going to read the CSV file, and you can see that these are all of our ones and zeros. And so you can see, but one thing that I forgot to do, and I'm going to see if it helps my reading. I'm going to run it. I just want to see if this improves my accuracy. We're going to run it again. So it doesn't really look like it's done anything to the accuracy, but we're going to save it. Oh, sorry, we have to, yeah, we have to save it. Doesn't look like it affected the accuracy, but you don't really need the ID. And the reason why you don't need the ID is because every row of data is indexed. And since every row of data is indexed, you don't need the ID, so you can just delete that or drop it. So now what we're doing is we're resaving it. I just want to see if it improves the accuracy when you drop the ID, because that is actually redundant information, and you don't really want any redundant information on it. Okay, so it's done. So we want to open it in the viewer. Okay. So we look at our data. Still got our data submit. I will say one thing, that if you wanted to, you could do the predict proba. It very slightly remove the accuracy. But what I was thinking, though, if you want to do the predict proba, you could call up the predict proba, and then you could like fine tune it so that rather than, if the predict proba for number 1 is 0.5, you get a 1. You could change it to 0.55 to get a 1, or 0.6 to get a 1, and that may very well improve your score. That's something that you could do. So I'm still on number 3, but I did actually improve my score. That's something that you could do, and I might very well do that. I might very well like fork off my submission and try out predict proba and say, if the predict proba is 0.55, then it's a 1. That's something that you could do to try to improve the score, because you can see, if we come over here, if you come over here to my submissions, and you can see it just very slightly improved my score. So you can come over here and you can see that you had more 1s. That's one thing you can see. That's what I might do. When I finish this video, I might go ahead and do a predict proba and see, and then change the predict proba to from 0.5 to 0.55 and see if that improves my accuracy. That's one thing that I can do. So I'm going to go ahead and conclude this video because we went over the code and then we made a change in the code. But I'm not going to do the predict proba in this particular video. What I might do is I'll do a separate video with predict proba and see what happens. So thank you so much for watching this video. Thank you to my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And I look forward to making more videos for you.